Okay, students. So last time we calculate the example of the Margulis model. So now today will be the last class for the chapter number that vapor liquid equilibrium, and we today we would like to calculate the remaining example. Uh, uh, Remaining example, like we have to calculate the create example regarding the calculation of that activity coefficient. So let me share some of the gate example regarding the uh, calculation of activity coefficient. Okay, so today we'll calculate 2 or 3 remaining gate example, and then we start new chapter that will be the chemical reaction equilibrium. Okay, so this is the example we would like to calculate. So the example is saying, consider a binary liquid mixture at equilibrium with its vapor at 25 degrees Celsius. Antonian equation is given for the system as log 10 P1 saturation is equal to A minus B divided by T plus C, where T is in Celsius and P is in torr. Then the Antonian constant ABC is systems are given in following table. So for component 1, A value, B value, C value is given. For component 2, A value, B value, C value is given. So vapor phase is assumed to be ideal and activity coefficient for non-ideal liquid phase reactions are given. Ln gamma 1 is equal to x2 square 2 minus 0.6x1 ln gamma 2 is equal to x1 square 1.7 minus 0.6 x2. Mole fraction of component 1, x1 will be the 0.11. Then the mole fraction of component 1 in y1. So y1 is equal to, okay. So let's try to calculate the value of y1. Okay, and we have to use these two equations. So first we have to calculate the two partial pressure. First we have to calculate the two partial pressure. So let's, for component 1, for component 1, log P1 saturation A minus B T plus C. Now what are the values of P of T? A is equal to 7.0 . V is equal to 1210, C is equal to 230. Okay, so if I do this, then log 10 P1 saturation is equal to 7.0 minus 1210 divided by C means 230. Now what is the temperature? 25 degrees Celsius the temperature. So plus 25. So can you give me the answer of the log 10 P1 saturation? Can you give me the answer of log 10 P1 saturation? Log P1 saturation is equal to 2.2549. Okay. So P1 saturation is equal to 10 raised to 2.2549. So it's 10 raised to 2.2549. It's a 179. 179.84. Okay. Now let's for the ln log 10 P2 saturation is equal to A minus B T plus C. A is equal to 6.5, B is equal to A is equal to 6.5, B is equal to 1206, T is equal to 25 plus C is equal to 2 to 3. So can you give me the answer of P2 saturation? Log 10 P2 saturation. Can you tell me the value of low P2 saturation? Ai que puta. Ai, so what is the value of low P2 saturation? 43. Thank you very much, Deepak. 43.3607. Okay, so P2 saturation is equal to 10 raised to 43.36. Ah, yes. So it's a P2 saturation is equal to 1.67 1.673. So it's a 43.36. It's P2 is equal. Okay, P2 is equal to 0. Okay. We shall give the answer. Okay. Log P2 is equal to 1.637. P2 saturation is equal to 43.360. So we get P1 saturation, P2 saturation. Now what we have to take? We have to find out the gamma 1 and gamma 2. For that, x1 is equal to 0.11 is given. So x1 is 0.11. So x1 plus x2 is equal to 1. So x2 is equal to 1 minus 0.11 itself is a x2 is equal to 0.89. So let's see the gamma ln gamma 1 is equal to x2 square ln gamma 2 is equal to x2 square 2 minus 0.6 x1 2 minus 0.6 x1. So x2 is equal to 0.89 square 2 minus 0.6 multiplied by 0.11. And ln gamma 2 is equal to, sorry, this was the ln gamma 1. Here it's a ln gamma 1. Ln gamma 2 is equal to x1 square 2 minus 0.6 x2. Sorry, here 1, it's like 1.7 plus 1.7 plus 0.6 x2. So x1 is equal to 0.11 square 1.7 plus 0.6 multiplied by x2 is equal to 0.89. So can you tell me the value of ln gamma 1? Zero 0.89 is to 2. So 0.79 to 1 is 0.6 multiplied by 0.11. So it's 2 minus 0.066. 2 minus 0.066. 1.934 multiplied by 0.79. 1. So 1.53. Ln gamma 1 is equal to, so it's gamma 1 is equal to 0.0. Okay, ln gamma 2 is equal to 0.027. Okay, this is 0.027 ln gamma 2. So gamma 2 is equal to e raised to 0.027. So if I do e raised to 0.027, it's 1.027. Okay, and here ln gamma 1 is equal to 1.5319. 1.5319. So gamma 1 is equal to e raised to 1.5319. So it's 4.6270. 4.6270. Okay, gamma 1 and gamma 2 will get. So we have an equation now. The equation is P is equal to y1 p plus y2 p is equal to x1 gamma 1 p1 saturation plus x2 gamma 2 p2 saturation. So y1 plus y2 it's a 1. So p is equal to y1 plus y2 is equal to 1. x1 gamma 1 p1 saturation, x2 gamma 2 p2 saturation. So there is no total p is given here, only 25 is given. So let's calculate p1 and then we can calculate the value of y1. So x1 is equal to 0.11 multiplied by gamma 1 is equal to 4.6270 multiplied by p1 saturation is equal to how much? It's a 179.84. 179.84 multi plus x2 is 0.89 multiplied by gamma to 1.027 multiplied by P2 saturation is equal to 43.360. Done? So what will be the total pressure? Can you tell me the answer in chat box? 80.23. 80.23. So now they ask us to calculate the y1. So y1 finally we get is equal to x1 p1 saturation gamma 1 divided by total p. So x1 will be the 0.11, p1 saturation is 179.84 multiplied by gamma 1 is equal to 4.6270 divided by total pressure is equal to 80.23. So can you give me the answer of y1? Okay, total pressure is 131.16. Okay, so it's a 131.16. So it's 131.6. So if here it's a 0. 0.69. So let's see whether we get any answer. 0.69. Is there any options or available or not? Yes, 0.69 is very near to 70. 0.70 is the correct answer. 0.70 is the correct answer. So it's very near to the. And so this is the example which is asked in GATE 2014. This is the example that is asked during the GATE 2014. Where activity coefficients are different and they are already given in the questions. Okay, the 2-mark question will be given. 2-mark question is there. If they ask y2, then what we have to do? 1 minus 0.70. So it's a 0.30 if they ask y2. Okay, so let's calculate another example like this. Let me share another example. This is also a very good example. It's asked in GATE 2010. This is a small example, but it's a good example. Okay. The example is an equimolar liquid mixture of species 1 and 2. Equimolar liquid mixture, GATE 2010. So equimolar means x1 is equal to 0.5, x2 is equal to also a 0.5. It means an equimolar. Species 1 and 2 equilibrium with vapor at 400 Kelvin. So temperature is given 400 Kelvin. At this temperature, vapor pressure of species P1 saturation is equal to 180 kilopascal and P2 saturation is equal to 120 kilopascal. Assume Raoult's law is valid. What is the value of Y1? So it's a equilibrium pressure will be there, and here it's the Raoult's law. So ideal solution is there. So it's a very easy. Very easy. So Y1P is equal to X1P1 saturation, Y2P is equal to X2P2 saturation. Just activity coefficient is absent, rest remains same. So if I do the addition of this one, Y1 plus Y2 multiplied by total pressure is equal to X1P1 saturation plus X2P2 saturation. हाँ बोलिए सर. X1 value will be the 0.5 multiplied by P1 saturation is equal to 180 kilopascal plus X2 is equal to 0.5 multiplied by P2 saturation is equal to 120 kilopascal. So can you give me the value of total pressure value? Can you give me the total pressure value? Okay, 150. The total pressure is equal to 150 kilopascal. Okay, thank you, Deepak. So now what we have to find out? We have to find out Y1. So Y1 is equal to X1 P1 saturation divided by total pressure. So 0.5 multiplied by 180 divided by 150. So 0.5 multiplied by 180 divided by 150. So it's a 0.6. Y1 value will be 0.6. Is there any option? 0.6? Yes, D will be the option. Answer is okay. A very easy example. Let's see is any other examples available or not. Okay. Uh, let's calculate last example. Then we stop here. This is not an example. But yes, this is the example. But the equation I doesn't tell. Okay. We'll do it afterwards. 10 2003. It's also I think we calculated. Okay, 1994. Okay, this can be done. Okay, 1994. An experiment, yes, this is the example. It's very good example. An experiment determination of a vapor liquid equilibrium state 1 ether, state 2 acetone. Binary mixture is given. X1 value given, temperature is given, Y2 value given, total pressure is given. Saturation vapor pressure, so P1 saturation, P2 saturation as 40 degrees given. This one. Vapor phase assumed to be ideal. Calculate liquid phase activity coefficient. Gamma 1 we have to calculate. Gamma 1 we have to calculate. Okay. So let's try to calculate this example. So gamma 1 and gamma 2 both we have to calculate. Okay. So how to calculate gamma 1? So we have to calculate x1 will be the 0.3. So x2 will be the 0.7. y2 will be the 0.42. So y1 is equal to 1 minus 0.42. It's a 0.58. So x1, x2, y1, y2 we have. Total pressure P is given 10 raised to 5 kilopascal. Then 10 raised to 5 pascal. It's not kilopascal, but it's a pascal. So P1 saturation is given 1.21 multiplied by 10 raised to 5, and P2 saturation is given 0.56 multiplied by 10 raised to 5. Done. So y1 P is equal to x1 gamma 1 P1 saturation. So liquid phase activity coefficient. So gamma 1 is equal to y1 P divided by x1 P1 saturation. Y1 value is given 0.58. Total pressure is given 10 raised to 5 pascal. X1 is given 0.3 and P1 saturation is given 1.21 multiplied by 10 raised to 5. So can you calculate gamma 1? Gamma 1 we have a 0.3 multiplied by 1.21, so it's 0.58 divided by 0.6363. 0.58 divided by 0.363. So 1.59. Gamma 1 is equal to 1.59. Same way gamma 2 we can calculate. So gamma 2 is equal to Y2P divided by X2. P2 saturation is equal to Y2 value 0.42 multiply by total pressure 10 raised to 5 divided by X2 will be the 0.7 multiply by P2 saturation is 0.56 multiply by 10 raised to 5. This one will be cancelled out. Zero point 392. So 0.42 divided by 0.392. It's a 1.07. So these are the two activity coefficients we are getting. Then so this is the first part we can. Now the second part, we do not give the G divided by RT, so we left this B part. Okay, so now this is from my side. If anything from your side, you can ask me. So these are the GATE example is asked of current topic. And next class, next time we start within the new chapter, and then new chapter with the chemical reaction equilibrium. We'll start within the last chapter, chemical reaction equilibrium, then we go further. So this is the end from my side. Thank you for attending. Take care of yourself. Okay, so I end meeting here for all of you. Okay, thank you very much for attending.